1 Pacific Coast time, so I'm a minute late. Welcome to this overview of FEMAP version 10.2. And if you guys have been to my other presentations, you're going to know that it's not always perfectly polished because it's live and it's not a demo. So I don't like to practice things too much. It makes it a little boring for me. Plus, you guys get to see all the little secrets if things get messed up. I want to bring up this PDF more just for me so I don't forget to do anything. And I'm going to send this out to everyone that was on the seminar too. So that's just sort of the guideline that I'm going to go through. Again, more stuff in Meshing Toolbox, post-processing, completely new, a lot easier, one-stop shopping. Very nice. Topology Optimization. I'm not going to talk much about that. That needs to be sort of a separate seminar. NX Nastran 7.1, Nastran thermal flow, and so on and so forth. This is the one slide that I think is quite interesting. I'm glad they put it in there because in the past when you've done your modeling and done your meshing, you build your geometry, you set things up, you mesh it, you run analysis. Then you got to go way back to the beginning, hack on the geometry, set the meshing, mesh it, go back again. What they're trying to do is get everything interactive. Every time you make an investment in prepping your geometry and your meshing, you don't have to go back and do it all over again. You can just focus on the spot that you want to work on. Everything else stays the same. You can go on and attack that one spot, get it done, move on, mesh it. And that's what they're referring to down here in the corner. Much more efficient, back and forth. And I'm going to do a little example on how that works. So this is the Meshing Toolbox. There's a section on these controls in here. This is for studying meshing attributes on a surface. They're in FEMAP today in 10.1.1. The challenge is they're a little bit here, a little bit there, and they put it all. But this is all within the Meshing Toolbox. So, and this is like, for example, the Geometry Editing Toolbox. I'm going to show how to use this. In the past, you would go in, you would split your geometry, you'd put washers around it, and then you would mesh. If you meshed the part and you needed to put a washer around something, you had to delete all the mesh, go back around. Now what you can do is you can do this within the Meshing Toolbox. You can update geometry and the mesh will change for you automatically. Very, very sweet. Meshing Toolbox, feature editing. This is going to be my first little live presentation. Feature editing, how to move things around and run analysis. It's pretty sweet. I'm going to jump in and do that now. I don't want to get in just showing the boring old PDFs without some live stuff. If you just wanted to see a PDF, you could go ahead and just look at it yourself without having to listen to me talk. So, this little box here, this is within the examples, the FEMAP shipping examples that you bring up. It's in the geometry file, it's labeled mp.stp, it's STP file. It's a symmetric piece of geometry, so I'm going to go in and cut it in half. Solid geometry, solid slice, and comes up with the default plane locate. I still remember the early days of using FEMAP, and I would enter in the exact numbers to get my plane right. And I was always afraid to touch methods. I don't know why, but it was just like I wouldn't explore. I said methods, and I've gone to use. I just use a few things because I know how to use them. Global plane. I'm going to slice it along the GX, and then the little secret handshake. Because what I want to do is I want to slice it right down this middle. I want to slice it. I want to point right in that midpoint of that curve. So what I can do is I can do a Control Z. While my cursor is within this box, I'll do a Control Z, and I'll bring up this locate. And I've mentioned this before in other seminars, but this is I like sort of repeating some things every seminar. So you can see it brings up this box, midpoint. Watch this. I'll hit OK, and I'll return that spot in the X, Y, and Z coordinates. And then I'll hit OK. I'll slice it. We're going to use a lot of the tree. And I'm going to right click, delete. So there I'm down to half the geometry, which I want to use. And I'm going to go ahead, mesh it. Watch this. Right click, tet mesh. It's going to be some aluminum material. There. Meshed. And then you can see all the dots, all the nodes. And I'm going to go to the view visibility. I'm going to turn off the nodes. Heck, I can turn off the geometry. I don't need it for now. Then it's much light and fluffier. At this stage, I want to set it up for analysis. I want to apply the constraints and the loads to this part. And I'm going to do it. I've done them before where I'll go through the tree. And I try to make this a little bit more advanced sometimes. I'm going to use the selector. I'm going to pick surfaces because I'm going to apply my constraints onto surfaces. And I'm going to have more than one surface, so I need to select multiple. And watch this. You can see it highlights and it picks those two surfaces of symmetry. And you see this now is charged up and the selection list says two surfaces. I'll right click into a blank spot, constraint. I'm not going to give it a title, just say sliding along surface. Now I'll clear out the selector. Then I'll punch this once and I'll go back to where I was before. And it knows I'm using the middle mouse button to rotate. And I pick those, right click, constraint again, and I'm just going to pin them. That's it for the constraints. Very, very slick. Now I'm going to clear this. Go back to surfaces, I'm going to do loads. And I want the loads to be just on that inside face like that. Right click, load. And that load is going to be a force in the Y direction. And I'll give it something wild like 5,000. It's in newtons. So there's our total load applied. Pretty slick, huh? It's one of the things I like to do occasionally. YouTube can make FEMAP very easy to use. So at this stage, we've done everything we need for analysis. We've meshed the part. We've applied boundary conditions. So I can go to Analysis, Manage, New. It's going to be an ASTRAN. And the only thing I want to set here, because it's a 10-node TET model, is to use the element iterative solver, which is tuned for 10-node tetrahedrals. Not plate models, anything, just 10-node TETs. It's super fast. And that's it. I'm going to run it. And while it's running, I'm going to go on visibility and turn off all the loads, turn constraints. And you see we still have that coordinate system that was used to define the plane of symmetry. It's done. It took 11 seconds. Not bad for 26,000 nodes. So in the old days before 10.2, you'd right-click under results and you could do your contour and you think, well, they give you this post-processing. I'm going to close this. And post-processing pane. Now, you guys, I hope this is, you remember that how to go ahead and arrange your panes. You know, you can slide them around, you can double-click and move them, and it comes up with this little baseball here, how to organize things and like that. Model info, entity info. I don't want entity info. I want that down below, like that. There we go. Okay, I'm going to go on post-processing. A little detour on panes. I want to do the deformed, and the output set is going to be NASTRAN. There you go. Now that is scaled on percent of model. If we didn't like that, one of the actual deformation, you could go like that. They give you a little plus sign. I hope you guys can make that out. I know on these webinars it can be hard. There's 100. Let's see what 1,000 looks like. There we go. There's some movement to it. I want to get rid of that triad in the corner. So you can always go to visibility. I'll turn the coordinate system on. Now, with that done and deformed, let's do the contour. NX NASTRAN. Let's pick an output vector. I want to do got to go up. Solid von Mises stress right there. Okay. So there we're at 467. And, it looks somewhat reasonable. And one of the things we would notice on this part is that for this load case, these ribs here do nothing. Absolutely nothing. So let's go in here, turn off contours, turn off undeformed. Let's get rid of those ribs since they're not doing anything. So we can go in the Meshing Toolbox, and I'm going to go to Feature Removal. I'm going to go to Surfaces, and I'm going to pick, this is your single pick when you just want to pick one thing. This is for picking Dialog Select, and I'm just going to go in and pick the two opposing surfaces of that rib to remove the complete rib. And so I'll pick the highlighter. Those are the surfaces of ribs I'm going to get rid of. I hit OK. Done. Like that. And then you could go back in, hit Analyzed. Dun, 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 dun. Okay. It just always gets me how fast it is. I actually ran it, first way I did this presentation, I ran it with a regular solver. It took 30 seconds. It takes like 5. Deformed. You guys have already seen this. Why? Because we have 2 load sets in there. A contour, second, no contour. We want to contour like that. And actually, the stress went down a bit, getting rid of the contours, because it allowed it to be a little bit more flexibility here on the side. Now, being the clever folks we are, we would look at this and say, well, look at that. That's where the hot spot is, 400, because these rib is right near this transition. So let's move these ribs inward. Let's move these ribs. Since the load is right here, we'll get more bang for our buck by moving the ribs inward. So I'm going to go back. So see, this is sort of multi-useful. You're going to see the post-processing interaction back and forth. And now I'm going to use something else in the Meshing Toolbox, which is not feature removal, feature editing. And I'm going to work with surfaces. I'm going to translate them. And it says, okay, what direction do you want to translate? I want to move them. I want to move it in the X direction. I'm going to move this rib in, and I'm going to move it 10 units. Now let's pick some surfaces. Like that. There we go. We move that rib in. Now let's reverse this thing for the other rib. We're going to switch it around, move it that direction. And I am recording this. So if you're going, you missed something, you can look at the recording. Hey, but you can also call. You can all call, send an email, and say, what was going on in that? I missed that. That didn't make sense. So there. Boom, 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 boom. Okay. Come on, it's taking 10 seconds. What's going on here? Done with that, let's go back to the post-processing pane. Deformed. And again, you gotta pick. It only works in the case that you're going to tell it to work. It only does what you tell it to do. Contour. Voila. So there. We started out with about 470 in stress units. We went to 400, now to 345 by moving the design around. And very quick, very fast. This is my favorite form of optimization. You can't beat the human mind. You can't really beat just looking at stuff and figuring out the load path and doing some quick little studies. There will always be jobs for good engineers to move things around. So that takes care of that example. I'm going to go back to here. So that's feature editing. You can do it with skins too, of course. You can move all sorts of things. The online help for new features goes in and talks about how to use the whole thing. It's quite good. So this is talks about moving. This is the solid part. Post-processing output data. For people like us, we've had models with 4 gigabytes of output results, and we try to combine stuff, and well, not pretty. It would take several hours to do processing. Now it's in seconds. He just rewrote the complete database. And I talked to the development team yesterday about, okay, you got 10.2, what's coming down the pike? They've already said that they're rewriting the database again. They rewrote it 9.31. They're going to rewrite a whole again, and they say they're going to get something like 10x faster on all reads and writes, all nodes and elements. So everything is always getting faster, a little better. Beams. This is novel. This is totally cool. For you guys that have been using beams, you probably understand they're the most powerful element in the Nastran library. They're absolutely fabulous for doing optimization studies, quick, down and dirty, but they have limitations. The limitations are that you really can't get detailed stresses on the cross sections of any complicated shape. It doesn't take into account torsion. It'll give you a torsion force, then you have to take the maximum calcs, and then you can take your torsion and then go through a hand calc to get the derived stress correctly. It's some limitations. It's a little bit scary at times. Well, that's no longer. Watch this. I dug out this cross section. I had it from a prior project, and it is just totally interesting. So this is a solar panel setup, and it's to be set up to mount on rooftop structures, and you get wind loading, and this is just a glass on top, and the panel sits underneath it, and this is the strut that holds it onto the roof. And the strut it's pinned down here in the edges with steel clips, and this is an extruded aluminum shape. And we are going to do a beam model of this shape and analyze it. And I'm going to take you straight from the beginning, and as you know, I really don't like doing demos. This is real engineering, and you're going to see maybe a little bit more difficult stuff than you might say, how come it's not easier? Well, I want to say real engineering modeling, this is about the easiest it can get. So we're going to make a beam out of this, put some loads on it, and analyze it. And what I need for my beam modeling, I need a curve in the middle of this cross section. So I'm going to go into geometry, curve line, coordinates. And I want to put my line in the center of gravity of that surface. Look at that. So that's 1 point. Middle mouse button, control middle mouse button, shift middle mouse button. Because I'm inside another box, I'm using the middle mouse button. Pick that. There's my curve right there. Now, while I'm working, what I want to do with that curve is I want to split it because these are the load points for the panel. So I'm going to modify, break, and I want to break that curve right there. I want to make sure I pick it there. So I hit the little highlighter. And I'm going to break it at the center of this tube. Yeah. Okay. Shift middle mouse button, bring it around, and I want to pick that curve. I'm going to break it again, right there. Now I'm going to turn the geometry off by the tree. I'll right click, hide all, and there's my curve for working on things right there. Just want to do a check. I'm going to bring it back, show all. Now let's make my beam property cross section. Oh, I'm not making you guys dizzy by moving around. So let's go down to Model, Properties, New. I want to use, it's behind my WebEx screen. Come back over here. Where are you? I know, you cannot pick because I didn't want to pick that. I'm going to do a beam, and I'm going to call this PVT Solar. support. Cross section. Material. It's going to be aluminum. It's linear elastic. I don't need to worry about too much. The shape. General section. Surface. That's the surface. It wants an orientation direction. Let's pick one. And then it'll draw, what it'll do, it'll calculate that cross section. And it'll appear, and this is the up direction there, the Y. And Z. So if you mesh it A to B, this will be the orientation. I'll click OK. OK. So we're done. We have a beam cross section. So I'm going to go back in, turn this off, hide all. So now I can go in and mesh it. And my mesh sizing, I'll just set the default sizing to 4. And let's go ahead and mesh curve. There's only 3 curves. PVD solar. Then you need your beam orientation vector. Like that. Then if we want to see what the cross section looks like, I'll turn it on. Now, let's do a little verification to make sure that things, I got it right. So I'm going to turn on this geometry. And you can see it doesn't line up quite right, that this needs to be flipped around, because when the Z direction, when it meshes, the way it lays down the elements determines that Z direction. But you can go to Update Elements, Reverse, where is it? It's Line Element Reverse Direction. The things, this is what people find scary about beams at times. It's like, okay, there's just too much stuff to keep track. So what I did is reverse the direction so this thing. Then you're going to say, well, what's this? It doesn't line up. This is maybe more beam theory than you want to know. That has to do with the beam offset, neutral offset. So if you get rid of that, voila, perfect. Now, before I get out of that, I want to bring this up. Standard beam theory, all you get is 4 points for stress recovery. You get no idea of the information, what's going on inside. You just get 4 points. You can move those points around, but at the end of the day, that's all you get. So I'm going to go load this up, and we'll get to the interesting part. Hide all. There's our beam section. Hope you guys aren't sleeping yet. I'm going to apply some loads and run it. Since our theme today is a selector, I'm going to use it again. And now we're going to work with points. We're going to work with nodes. And I'm going to have more than one node to work with, so I need to select multiple. So I'm going to set what do I want to do here? I'm going to just go back. I'll do the loads first. You don't have to do it in any particular order. So there's that point and that point. And the load will be 500 pounds pulling up per node at that point. So that is the wind load pulling up on our beam from the panel. Now I'm going to clear the selector, punch it again, it'll come back to nodes. Take that in point, and I'm going to give that a load. I'm going to give it a moment around the Z-axis of 1,000. And this represents the panel twisting and tweaking this beam section around. Okay? Now I need constraints. So I'm going to clear it, and I'm going to pick this point right there, and I'm going to constrain that. I want to constrain it in the X direction and in the Y direction. Then I'll clear the selector, go back, punch that for node. Now I need the constraint on this end. And on this end, I'm going to constrain it in all 3 directions, and I'm going to keep it from spinning. This is to resist the moment load, RY. So that takes care of that. Analysis, manage, new, analyze. There, 2.828 seconds. Another reason why people like beams. So let's go into post-processing again. Deformed, output set. There, this always gets me about some, when you work with the percent of models, like, what the heck? So, we can always, instead of being 10%, we can make it 5%, like that. That's fine too. Contour. See what we get to work with. For simple beam sections, this is your von Mises stress on the surface for very simple beam sections. Like that. And now, we're not going to contour, we're going to do a beam diagram. Everyone loves that. Just like, what the heck does that mean? Show as beam contour. There. Now you can see that on your screen. You get 3,825. That is what your standard combined stress is at the 4. When it looks at the 4 stress recovery points, it'll pick out what point is the maximum, and that's what it's contouring. Simple stuff, that works pretty well. I've been using it for years. Whenever you get torsion or something weird going on, you got to do your hand calcs. So let me go. I want to turn off the geometry. Yeah. But you can imagine for this cross section, give it up. That's not going to work at all. So let's show what they've done in the new. I'm going to turn off thickness like this. Now you're going to go into View, Advanced Post, Beam Cross Section. So that's View, Advanced Post, Beam Cross Section. And I'll come up with this, and we're going to use this case here, and I want it to calculate the von Mises stress. And for complicated sections, you should go to Advanced and up the quality, because what they're doing is they're actually meshing that cross section with 2D elements and applying the loads and calculating. This is a full-on. I'm going to put on the section outline to make it look pretty. This is a full-on stress calculation. And I'm going to do, just for start out, I'll just do all elements. There are only 10. And it will go through, it calculates everything. Look at this. It gives you the full-on stress through the beam. That is the real stress contour in that beam under these loads. And you can see the stress value, 41,000. Remember when we did it just in the max min, it was something like 400. What I want to do is, if you want to see where the maximum is, you can slide this. You can pick this beam right there. Hold on, I'm going to pick this element. There. There's 41,000 peak stress. If you pick this one here, you can see 34,000 in the middle, things like that. And here you can look at that cross section, and you can see where the problem is in your cross section where you're building up load. Right there. Really quite amazing stuff. There, your cross section. If we go back and just get out of that, and go back to old school, turn on the cross section, and let's go back. Beam, results, contour, no contours, beam diagram, 3,825. Pretty stark. I was surprised that there was that big a difference. So, okay, that is the world of beams. And of course, you can do multiple sections. You can take one beam, slice them up. You can do all sorts of nice stuff. Right. And this was written by, I believe, William Cobb. I want to give him praise. I'm pretty sure he wrote it. It with help from the rest of the team. So, post-processing, we've been working on that. Topology optimization. This is a free-form topology optimizer. You give it a block, you apply the loads, and it will chew through the block to optimize the structure. It's something that it takes a little time to set up, as all these optimizers work. The key concept is, first you have a solution that works. Then you take your block and you optimize that block to something that's more cleaner, simpler stuff, but you always have to start from a known point, and then it'll chew through it, removing material that is not needed. So, and this is an example of a torque block, and what it does is the final end, it hollows out the middle and carves off the end. So, glued connections, edge to face on it, and bolt preload contact performance, quite big. I did have an example to do this to show how the difference in timing on the bolt preload, but it just wasn't quite that exciting. I mean, it's something that you guys can build models. You're going to see right away the difference. It used to be that you're running 2 complete nonlinear analysis, and it would take 2x longer with bolt preload. Now it's like 1.5 times. It really taken a lot of that out. Glued. I'm going to stop here because I have another example to go through. It's more fun. Okay. Okay. Where do I want to start with this? Do I want to start with raw geometry? Yeah, I think I do. You guys probably get sick of me at times always doing, surface modeling. It's like always, okay, here he's going to go again. He's going to make surfaces and he's going to glue stuff together. It's just so effective. I always wonder if people are missing some of this, and I always want to sort of go through it again. So I hope you guys permit me to do this little regression and modeling. So I'm going to use the tree again. I'm going to turn this backside bracket here off. Boom. I'm going to mid-surface these things. Okay, where am I going with all this? I'm going to mid-surface it. I'm going to stitch things together. I'm going to glue it into a non-manifold, and then I'm going to mesh the bejesus out of it using all the meshing tools in the meshing toolbox. And then I'm going to analyze it and do some cutting on it. So it covers a lot of surface modeling techniques. So my first stop is mid-surface, automatic. I know all these things, it's thickness of 0.9, 0.09. I can just give it a little bit more, give it 0.1, off to the races. I can turn the solids off like that. There we have the skins. Now let's go to solid, stitch. Let's just stitch these individual, infinitesimally thin solids into one sheet solid. Well, excuse me, 2 sheet solids. And you can imagine surface solid stitching. And so it comes back. You see the tree here? All of a sudden it went boom, boom, boom to just a stitch body like that. So now we have 2 stitched bodies because they're separate. And for plate meshing, that's not so good. Yes, I could take this demo and do the new edge contact thing. And edge contact here and show how you can make an edge contact with this model. You don't need to extend, but I want to make it continuous because this is a welded part. So then I'm going to go back to geometry, mid-surface, extend, pick, and then I'll verify here. Yes, those are the curves I want to use. I'll hit that thing again. Hit OK. I want to extend them to this solid down here. So what I'll do is I'll go and extend and slice. And on these operations, you're really hacking on the geometry in the Parasolid engine. And for housekeeping, it's good to go to geometry solid and clean up before you start digging in too deep. And what I'm going to do is pick these 2, and what I'll do is I'll go back in, remove anything, and check geometry. And if you're really observant, you notice it resplit this curve here. It was 360 degrees. It resplit it. And it just sort of cleans things up. So now with that done, I'm going to go to geometry, surface, non-manifold add. Non-manifold because it ain't continuous. This is a right angle. And it's easier if they're all just hooked together. You see, once I did that non-manifold add, it goes general body add, and it's all sealed up for meshing. So from that point, since it's our selector day, surface, I want to pick multiple. I'm holding the shift key down, left mouse button, select, right click, mesh size default. I want to throw a mesh on these, right click, go in, go to mesh, and I can do it straight from here. There's no reason I have to be fancy. Plate, some sort of aluminum, boom, boom, there. And if I want to do a quick check on thickness, okay. And maybe in the past I might have said, okay, that's good enough. Let's just go ahead and use that, be done with it. Oh, I got to turn the orientation off. There. But I've gotten much more pickier about my meshes. And I'm going to turn off the geometry, turn off nodes. Let's go in and use the meshing. You guys know, he's going to go and use the meshing toolbox again. I'm going to get rid of that little piece of garbage there by feature suppression. It's a curve. And that cleans that up. Now, this is a stage that's really common. It's like, well, God, I wish I really want to put washers around here because I know I'm going to be attaching surfaces and bolts. And in the past, you would have to get rid of all the mesh and you use this. This is you guys probably know what this is. This is the curve on surfaces bar, which is all these geometry commands here and a handy dandy little bar. Well, of course, now what we can do is we can go into feature editing. Geometry editing, washer, and off this distance I'm going to make it 0.15, and I'm going to pick a bunch. I'm going to use the multiple pick here, and you just need to pick one of the. It just wants one side. There you go, washer ahoy, like that, and we know I know I'm going to get lots of high stresses in this part here. So this is where I want to clean this up a bit and split it. So I'm going to use this split here, point to edge. And it picks a point, and then you pick an edge. Pick a point, pick an edge, like that. And likewise, if we wanted, we could also split it from here to here. You can go on and on, but this is just some of the commands for breaking stuff and moving things around. Now I'm going to go to mesh sizing, like that, increase. And likewise, I can take this corner here and you can just sort of play with the meshing. And also, I like keeping the entity info pane, that's under tools, entity info, on in the thing, because when you're working on this, it'll echo. It'll tell you what your elements are doing. So there's 8, 9, so you set that up like that, you can get a little bit better mesh quality. There. There. Voila. And one of the things, too, is when I look at this and I go, well, I don't. You can see you can really sometimes get a little mesh crazy playing, but it doesn't really suck up too much time. There. What do I got? 14. You can see I'm doing this completely live. I'm not. I'm winging it, which is, I think it's a good thing. There we go. That looks nice. I'll give this another few more on the corner, and that's about it. For you guys that might not have seen some of the new meshing in for a while, I hope you're appreciative that the overall mesh quality that is generated is just so much better. I mean, it's such a big leap over the last couple of years. So, okay, let's go ahead and load this. I want to just do a quick run because I want to do the post-processing for plate elements. Oh yeah, we got 911. I might as well show the last little contact. People, I want to see contact. So let's turn on geometry from there. And let's go ahead and do that backside brush bracket. I'm going to do it hex mesh. And I want 2 elements through the thickness, like that. I wonder what I did wrong. Mesh size. Well, it works, because I just punched it and I didn't bother. Let's see what it's... There. Oh, okay. Now let's hex mesh it. Solid property. Boom. So there's our backing for our solid mesh. Okay. From this point, what I'm going to do is load it up here. Let me turn off geometry again. I'm going to go ahead, load it at here at the top. Hold on. The audio cuts in and out for me too. I saw that on the thing about for audio performance, and I don't know why. Unfortunately, the life and times of internet connections, because I don't have any other applications open on my desktop. It's just this. Oh, I know what it's doing. Since it's recording and burning on internet, when FEMAP is doing a processing operation that's taxing, I think that's why the audio is cutting out. Sorry about that, gang. So I'll go ahead and continue on. I'm going to put bolts on here. I'm going to pull it on here. I'm going to set up contact and run it. And then we'll do post-processing, and we're done. So let's go ahead. I'm going to set up the bolts, and I'm going to use my own little API for doing a spider and a bolt. And you can download this from our website. And I'm going to use surfaces, and I'm just going to grab that surface and that surface, and the inner surface on the backing plane, and it create a new property with specified diameter. Bolt diameter is 2, and I want to make a new material, and I'm going to make the bolt out of steel, like that. And then you can go right-click, previous command, and it'll take you back to the API. There. And there's our 0.2 volt, like that. So now I've created the bolts. Let's go in and create the loads. Same gig, surface. And I got multiple set up. So, I want to make sure I cleared the selector. And I'm picking these surfaces here. And let's give it a load. And I'm going to push it back. And the total load pushing back is going to be 100 pounds in the minus 100 pound direction. Like that. So this is an action that's going to push against this backing plate, like this. So then I'll clear this, punch here, goes back to surfaces. And I want to pick these edges here. And sometimes it's a little a little difficult, and I want to do pick to front. And when you're in the selector mode, to switch the selector to the default, you hold the Alt key down, right click, and I'm going to pick front. And then it goes back. What I'm going to do is just constrain these edges. Like that. Constraint, pin. There we go. We got load, we got a constraint. Everything is ready to go. I'm going to do static analysis. I'm just going to run this without any contact for the first run. So in this analysis, what we're doing is we're just saying, the only thing is we just have bolts. We're just holding it. That's done. So there's our results. Everything looks good. Post-processing, deformed. There's our case, like that. And that is just the weirdest. Now you know it's really not live, because why would it be twisting like that if the load isn't cut? Oh, it's analysis. It's you guys see that right there, don't you? It's fixed. So let's go back to surface. Pick that right there. Constraint. No. What do I want to do? Oh, I got to go here. I've never done this before, but I know there's one for constraints on surface. I can pick that and go edit. Right. And what I want to do is delete. So it's not letting me delete quite from the tree. I'm sure if one of the developers are watching, they say, well, yeah, of course you can delete from the tree. You just got to do this. Constraint on surface. Edit where applied. Okay. Sneaky. Okay. I remove that. Good. Let's rerun it. Okay, it's 9:18. I am going to finish on time. I try to make these things last absolutely no longer than an hour. So, post-processing. Output set. There we go. Just like that. And symmetrical, more or less. I'm going to turn off some things. It's turn off all these, turn off all the constraints. And it's 67,000. Pushing back against that side. So now let's do contact between the two parts. Model info. And I am going to show something new on contact. Contact. When in doubt, hit the defaults. So that's our contact property card. Our regions. This is a new one. For solid elements, before you had to pick faces, fool around with that. Now, if you just pick the property, it will calculate the faces, the exterior faces for the contact region. And for the plates, I like being very explicit about my picks. Like that. So that's going to be for that face contact. Then you need a connector to join them together. Solid plates, like that. And then we'll analyze it. I'll go into visibility, turn off the connector, like that. So it's going through the contact convergence. And done. like this. And obviously, that didn't work. And I'm pretty sure I know why. It has to do with, well, this is always on contact. Sometimes I'll jump to, oh yeah, it didn't work. And I've learned that, okay, before I start blathering, let's go in and look at, when you're doing contact, you really want to scale it 1-to-1. So obviously, something is not contacting correctly. And this is why when you do it live, it's, as Adrian would say, you know that it has to be, and most likely it has to do with your contact on the parts. It's facing, surfaces facing each other, facing out. So what I'm going to do is I want to just look at, I want to go into post-processing. I'm going to turn off undeformed, like that. Go to contour, turn that off. Now as you can see how I would debug this if I wasn't in demo mode, is that I go in, let's look at just the plate elements, okay, like this. Now, let's see which of the normals are working. Okay, so the normals are facing inward like that, and when you're doing contact, you can see the numbers too. I can turn off labels. You want your normals facing against the region of contact. And we could also go into, I'm pretty sure, that's why I wish Adrian was here. I want to flip this. Hold on. I know there's a way to do this. I saw it once. There you go. Show it reverse, like that. Okay. What little sweetness. So what I did is I clicked on the region or reversed it. Want to see if that works. Contact, it's always things facing each other and debugging on that. Okay. We have a lot more contacts. And now, there's our, let's do the deformed. There. It's nice to know logic works. It's only the hard part is when I'm doing it live. I know everybody is watching. And it's like, okay, you got to be quick. Okay, so now with contact it's 38,000, and that's not a good output set. And this was original without contact at 67,000 and with in at 38 because of the backing plate. Last thing, I want to go in here to post-processing and go to contour. We're looking at and we're looking at plates. We also want to do an additional vector, and that additional vector is the solid von Mises stress right there. And there's some other things too. Is that we want to do double-sided planar because plate elements you have top and bottom. And then if we want to, we can go on and turn on thickness and turn off filled edges. Like that. Okay. I know there's just a little bit more. I swear I'm almost done. There's new RBE setup. There's force frequency response is now built in. This is a very important thing for people doing graphics. It's a graphical output. It's when you have, for example, let's turn on filled edges and let's turn on thickness. It's when you're making up your engineering report, and sometimes you notice that when you copy things, like copy picture into your PowerPoint, it's not as crisp as you want. File, Preferences, and it's under Views, Resolution, right there. And you can scale what you're seeing on the screen. You can up the resolution, screen scale by 2, or you can do it by 4. What that does is that when you hit this button, it will take your screen resolution and multiply it by 4x. So that when you go in and paste it into your handy-dandy PowerPoint, like that, it's a 4x resolution of what you had before. And you really will notice this when you start looking at when things start getting printing. It's a lot better. You see the lines here? That's the 4x resolution. If you had it at 1x the screen, that would be much jaggier. So you're going to get much higher quality presentation graphics now out of FEMAP. And that is the resolution key. File, Preferences. I wonder how many people would find it if they don't. Resolution. I just set it to 2. I mean, that seems to be plenty for all the reports. The last hidden thing is, this is quite, I think it's, I tell you, I even had to go look at the outline once and say, where did they put that thing? And I still have trouble figuring out where dynamic cutting plane. See, I went right by it. Or is that it? Jeez, I'm such sad shape sometimes. See, there's the graphical. Contouring, new contouring algorithm. Okay, where is that? General Nastran. Beam processing. I saw it in here. It is what it. Oh, I know. What it allows you to do is it'll cut through the model, and you're gonna have to take pity on me because I just started using it, and I know where it is. Isn't that crazy? Clipping plane. So it's under this view setting, clipping plane, and let's set the plane. I'll cut it through the ZX, and I'm going to make it. Hit the Control Z. I'm going to make it through the center of that hole, and then clipping plane on like that. So what they're going to let you do is that you can cut through the model at any place, any type, beam, solids, and allow you to visualize what's inside through a slice. Okay. Looks better without the thickness turned on. That is it. Since the audio is cutting in and out, I probably should get out of here while I'm somewhat intact. And I'm at 9:30. As always, if something didn't come through quite right and you're puzzled and you have questions, please email us, call us, and we'll get right back to you. This audio will be posted, and once I get it posted, what I'll do is I'll send out an email to everybody on the list with this PDF for the 10.2, along with the location of the thing. For getting the software, you guys should have, you're going to get the CDs in a couple days. You can download from the Siemens site to the GTAC site the complete new install. People say technical support web page. You can get to the download product update, and it's a full update. And so you can download the whole thing. Licensing, likewise, your administrator for the account can download a new license key you have any questions, any problems, give me a call. Thanks for attending. Have a great day. Bye-bye.